Hey everybody, today we are going to continue in our surface area with chapter 11, and we are going to be looking at the surface area of pyramids and cones. Okay, so in the last one we did prisms and cylinders. Today we're going to look at pyramids and cones. So remember, our pyramids and cones come to a point, and as we're looking here, remember that our lateral area is going to be the area of all of the sides that are not bases. So in our pyramid, we have one base. So I'm going to have my area of my base here, and then my lateral area will be the area of the other four sides in the square pyramid. But these sides are all triangles. So remember that the area of a triangle is 1/2 base times height. Okay, well, the height of these triangles is the slant height of the pyramid. Okay, and all the way around the bases is going to be the perimeter of the base. So just like we did before, and remember we're going to make this a capital P, that we're going to have 1/2 times the perimeter of the base times the slant height, because that's going to be the area of each of those triangles. All right, so that'll be our lateral area. And because we have one base, then we're going to add in the area of the base and not two bases like we did in the last one, because remember, prisms and cylinders have two bases. Our cones and our pyramids are only going to have one. So that's why we only add one B. All right. Let's take a look at surface area and lateral area for a cone. Again, it's going to be 1/2 perimeter of the base times the slant height. But remember, perimeter is circumference in a circle. Okay, so our circumference formula is 2 pi r. Well, half of 2 is just 1, so we can say that our lateral area formula is pi rl. And then again, we're going to add in the area of the base. So you will also see me write, you may want to write down, is pi rl plus our area of a base is a circle, so it's going to be pi r squared. Okay, so that's going to be our surface area formula that you're going to see me use a whole lot, is pi rl plus pi r squared. So the kind of nice thing here is that the 2's go together and then just like the single coefficients go together. So like for a cylinder, it was 2 pi rh plus 2 pi r squared. Well, here for surface area, it's pi rl plus pi r squared. So they kind of go together. And again, just like in prisms and cylinders, these formulas here are not on your reference sheet. So you need to make sure that you do know these formulas. All right, so let's take a look at an example. And I want to find the lateral area and the surface area of the pyramid. So when I look at lateral area, okay, my formula is 1/2 perimeter of the base times slant height. And then for my surface area, it's going to be my lateral area plus area of the base. So things that I need to make sure that I know that I have. I need to have the perimeter of the base. Well, okay, I'm told it is a square pyramid, so that means my base here is a square. So the perimeter of the base is going to be 9 plus 9 plus 9 plus 9, or 9 times 4. So my perimeter of my base is 36 inches. Okay, then I need to know the area of the base for when I do surface area. So my area of my base is going to be length times width, or base times height, or side squared, however you want to think about it in your head. So it's going to be 9 times 9. So my area of my base is going to be 81 inches squared. Then the next thing that I'm going to need is my slant height. Okay, well, I don't have my slant height, I have the height. So what I'm going to do here is draw in my slant height. And I'm actually going to make this, oop, not that. Nope, come on. There we go. I'm going to make this solid because it's going to be a little easier to see that it's on the outside. All right, so this is my slant height. Now, because it is a square pyramid, I know that this is the absolute center of the square, which means that if this whole side is 9, that this is 4.5. Okay, so I'm going to do my Pythagorean theorem because this forms a right angle. So I'm going to do 4.5 squared plus 8 squared is equal to my slant height squared. So 4.5 squared is 20.25. 8 squared is 64. That's going to equal L squared. And when I add these together, I'm going to get 84.25 is my L squared. And when I square root this, I'm going to get 9.1788 da 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 for my slant height. Now, my suggestion is you do all this first because this is, going to be a singular number. It's going to be easy to figure out. This one, we have this number here. Leave it in your calculator because, again, it's going to make us more exact for what we're looking at. So we want to leave this long decimal in our calculator because we're about to turn around and plug it in. So for my lateral area, I have 1/2 times the perimeter of my base, which we found over here was 36, times my slant height, which is 9.1788 da 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 da. Okay, so in your calculator now, all you have to do is put times 36 and then divide it by 2, or you could say times 18, either one. It's going to get you to the same place. That our lateral area is going to be 165.2 inches squared when we end up rounding this off. Again, we are in area, so our unit is squared. All right, surface area is my lateral area, so that's that 165.2. And again, my suggestion is to leave this in your calculator because it's not 0.2, it is longer, just in case anything over here is going to change that, which in this particular problem, it's not, because we're not dealing with decimals in the area of our base. But if I did have decimals in the area of my base, I would want to leave this number in my calculator. And you might as well leave it in because it's just easier to add. But we found that our area of our base was 81. So when I add these up together, I'm going to get 246.2 inches squared. So that is my lateral and surface area of a square pyramid. All right, let's take a look at another example. Okay, I want to know the lateral and surface area of the regular hexagonal pyramid. Okay, so then we want to round to the nearest tenth. Again, what I'm going to have you guys do is make sure that hopefully you recognize that when we have a hexagon, this is going to be a 30, 60, 90 triangle, and we're going to end up dealing with a square root. Leave it in radical form until the end because, again, you're going to be more accurate and things are just going to be a little bit easier. So let's start off by writing our formulas, and we can see what pieces we're missing. So my lateral area is 1/2 perimeter of the base times slant height. And then my surface area is my lateral area plus my area of my base. So things that I need the perimeter of my base. So my perimeter is going to be 6 plus 6 plus 6, da, da, da. So it's 6 times 6 because there are 6 sides. Because we know that it is because it says that it is regular. So that's an important piece of information there. So the perimeter of my base is going to be 36 inches. Okay, I'm given my slant height. My slant height is 9 inches, so that's kind of nice to know. And then I need to find the area of my base. So I'm going to use my formula for a regular polygon, which is my 1/2 AP. I've already found the P over here because it's still the base. So now when I look at my hexagon, here's my apothem. And remember that this angle here, let me change to a color that you can see, is that 360 divided by 6 and divide by 2. We're going to get 30 degrees. So again, I have a 30, 60, 90. So because this whole side length is 6, I know that this is 3 and this is 3. These are my short legs because they're across from the 30, which means that my apothem is 3 times the square root of 3. All right. If I wanted it, my hypotenuse would be 6. Okay, but I don't need that. So my apothem is 3 root 3. So now we can plug that in. For my area of my base is 1/2. My apothem is 3 times the square root of 3. And the perimeter of my base is 36. So I'm going to do 1/2 times 3 times 36. And I'm going to get that the area of my base is 54 times the square root of 3. Again, I'm going to leave this out of a decimal form. I'm going to leave it in radical form right now just because it's easier to put in the calculator later than try and keep this in the calculator or come back to it or any of that craziness. Just leave it in radical form for now. and then you can put it in the calculator once you're doing the final calculations. So, lateral area, 1/2 perimeter of the base, which we found was 36, times the slant height, which is 9. And when I put all of that into my calculator, I am going to get 162, and that is inches squared. Okay, then I'm going to plug over here for my surface area, which is my lateral area, which we just found was 162, plus the area of my base, which we said was 54 times the square root of 3. Okay, if I wanted radical form, that would be my final answer. But it does tell us that if we want to go to the nearest tenth, if we need to, so we do need to go here. So you can do in your calculators, that single line, do 3, hit the square root, times 54. Then from there, you can just do plus the 162 if you're like confused about how to put that in your calculator. So when we do put that in, this is going to be 255.5 when we round to the nearest tenth, and that is inches squared, again, because we are in area, so our unit is squared. All right, so that's pyramids. Let's go ahead and take a look at a cone. Okay, so my surface area and lateral area for my cones. Remember, it was that 1/2 for my lateral area, circumference, which is 2 pi r, which is the perimeter, times the slant height. And that 1/2 and that 1 multiplied to be just 1. So my lateral area is pi r L, and my surface area is pi r L plus pi r squared, because that's that lateral area plus the area of the base. Okay, so looking at things that I know here, I know my radius is 5, okay, and then I need my slant height. My slant height I don't have. This is my slant height, okay? 12 is the height. So again, we have a right triangle. We need to do Pythagorean theorem to find that missing side. So we're going to do 5 squared plus 12 squared is equal to L squared. And again, this is a place where those knowing a few of those triples can really come in handy, because I already know now that this is a 5, 12, 13 triangle. But again, Pythagorean theorem always can get you to the final answer, but it might be nice for you to not have to do it. But also, if your brain is full because you're memorizing too many other things, Pythagorean theorem it out. So when we square 5, we're going to get 25. Square 12, we're going to get 144. And when we square root 169, we're going to get that 13. Okay, so my slant height is 13. So now for my lateral area, my radius is 5 times my slant height of 13 times pi. And notice we're leaving things in terms of pi. So again, I'm just going to put 5 times 13 in my calculator. I'm going to get 65. So it's 65 pi meters squared. All right, surface area here, I'm taking that pi RL, which is my lateral area, which we just found was 65 pi, plus pi r squared. So my radius again is 5. I'm going to square that and times pi. So this is 65 pi, and then 5 squared is 25 pi. So when I add my 65 and my 25, I am going to get 90 pi meters squared. Okay? So now let's take a look at one where we're going just a little bit differently. This one, we're given the lateral area of the cone, we're given the radius, and I want to find the slant height. All right, so I know that my lateral area is 103 pi. My radius is 37, and we're looking for our slant height. Okay, so let's start. We're given lateral area, so that's the place we want to start. We want to start with our lateral area formula. So lateral area is pi RL. And we're going to just, from here, plug in what we know. We know that the lateral area is 103 pi. And then my radius is 37 times pi times my slant height, which is what we're looking for. So I'm going to start off by dividing both sides by pi, because then they go away. So I'm going to get 103 is equal to 37L. All right, divide both sides by 37. and I turned my page too far. So when I do this to the nearest tenth, I'm going to get 2.8, and that is centimeters for my slant height. Remember, this is a length, so it's just centimeters. All right? So let's go ahead and look at one more example. And this is a composite figure. Okay, so I want to find the surface area of all of this put together. What's important to realize is we're going to break this down into what is and is not actually exposed to the outside. So when I look at my total surface area here, let's just start at the top. Okay, I have a cone at the top, but notice that the base of the cone is on the inside of the figure. Like, I do not want to count this base here in my surface area because it's not on the surface, it's on the inside. So when I'm looking at my cone up here, all I want of the cone is the lateral area. Okay, so just the lateral area because I don't want to add in the base because it's actually inside the figure. Okay, now let's look at the cylinder. Okay, I know that if I go the whole way around the cylinder, I'm going to need the lateral area of the cylinder. All right. Then I need the area of the base on this bottom. So plus 1 area of the base. Again, with the cylinder, I don't want to do plus 2b because the second one is up here, and again, it's on the inside of the figure, so it's not on the surface, so we don't want to count it. So I have the lateral area of the cone, the lateral area of the cylinder, and then the area of this one base. So let's go ahead and plug in all of our formulas here. Lateral area of the cone is pi RL. Okay, lateral area of the cylinder is 2 pi RH. And my area of the base is pi r squared because it's a circle. So let's plug in all of our missing information here. So I know that my radius of my cone is the same as the radius of the cylinder, so it's 5. I don't have my slant height. Well, this is the same right triangle that was in example 3 on your paper, so we've already done this Pythagorean theorem. It's 5, 12, 13. So if you don't know how we got 13, go back to example 3, look at that Pythagorean theorem. That is where the 13 comes from, okay? So I'm just not going to do it a second time. So my slant height is 13 times pi. Now, 2 times my radius of my cylinder, because now we're moving into the cylinder, is still 5. The height of the cylinder is 16, and then we're going to multiply that times pi. And then again, the area of the base of the cylinder is that 5 squared times pi. All right, so if I want to, or find out what each one of these are. So we're going to do 5 times 13 is 65 pi. 2 times 5 is 10, times 16 is 160 pi. And then 5 squared is 25. So this is going to be 25 pi. So when I add together when I add together 65, 160, and 25, I'm going to get that my surface area is 250 pi, and that's going to be inches squared. So that's my answer in terms of pi. Now I also want it to the nearest square inch. So that means I'm going to put 250 in my calculator, multiply it by pi, and round to the nearest whole number. And that's going to give me 785 inches squared. So these are the 2 answers that we need to have for this problem, both in terms of pi and to the nearest whole number. Okay, again, if you guys have any questions on this, write it down somewhere on your paper and let me know the next time that you see me, and we will go from there and take care of any questions that you may have. I hope you guys have a lovely evening and afternoon. I will see you all later.